For each of the following problems, we want to solve and graph the or and inequalities. We'll start with number 1. In this one, in order to solve it, the or between these inequalities means that either of these scenarios can be true. Either we want to find an x that fits this first inequality or one that fits this inequality. Any solution from either one is a solution to the entire problem. The and inequality means whatever x values you find, they have to be matching between both of the inequality statements to be a solution to the problem. So, to this or inequality, let's start by solving each inequality first. We're going to move this x to the other side by subtracting x from each side. And then to get it alone on the left, we're going to add this 5 to each side. I'm doing 2 steps in one here, but you could easily separate them. So this leaves us with 2x minus x is just x, and negative 5 plus 5 is 0, which is less than x minus x is just 0, and 3 plus 5 is 8. So x is less than 8, or, now we'll move over here. We'll subtract 1 from each side to start getting our x alone, which leaves us with negative 2x is less than 4. And then dividing each side by negative 2, we get x and negative 2. 4 divided by negative 2 gives us negative 2. And remember, whenever you divide or multiply by a negative with an inequality, you have to flip the inequality. So our statements are x is less than 8 or x is greater than negative 2. So let's go ahead and start with the graph. We need all of our values from negative 2 to 8, so we'll just go ahead and put negative 2 and a number to the left and right of it. We'll say negative 3 and negative 1. And then over here we'll put 8 with a number to the left and right. So we'll say 7 and 9. And then the tick marks in between we'll just leave for the sake of not having to put a bunch of them in. Okay, so from here we know that for our first part, x has to be less than 8. So I'm going to use some colors here. I'm going to say that red represents this one, and I'll say that green represents this inequality. And you'll see why this will be important in a moment. So to graph x is less than 8, we put our parenthesis at 8 and shade to the left with an arrow pointing left. To graph x is greater than negative 2, we start with a parenthesis at negative 2 and we shade to the right with an arrow pointing to the right. An or statement says, look at your graph, both colors, and decide where you have shading. Anywhere that you have shading in either one is a solution to the entire problem. So notice in this problem, everything is shaded. The only 2 spots that aren't shaded are this parenthesis in green and this parenthesis in red. But in both cases, this parenthesis that's in green has a red shading on top of it, so that number is included. This parenthesis in red has a green shading on top of it, so that number is also included. That means every number to the left all the way to negative infinity and to the right all the way to positive infinity is included. So the solution to number 1 is negative infinity to positive infinity. and this is the graph that matches it. On to part 2. The and inequality, remember, like I said at the beginning, means that you have to have both values matching. Meaning when we get to the graphing step, we want only where there is shading from both colors. So if we start solving for x again, we'll subtract 4 from each side to get x is less than -2, and over here to get x alone, we'll start by subtracting 2 from each side to get 3x is greater than -12, and then dividing each side by 3, we get x and -4. -12 divided by 3 is -4. And we divided by a positive number, which means we keep the inequality as it was. So x has to be less than -2 and greater than -4, so we can start making our graph. We'll jot down our two values, -4 and -2. We'll pick a number to the left and right of each one. -3 and -1 for the -2, and then -3 and -5 for the -4. So from here, again, we'll use two colors, red for the first one, green for the second one. So when we start graphing this, x is less than -2 means we have a parenthesis at -2, and we shade left. And we put an arrow pointing left. X is greater than -4 means we put a parenthesis at -4, and we shade right with an arrow pointing right. Now remember, we only want the location where we have both of them shaded. So we're actually going to redraw this graph for our final solution. Nothing perfect, but it'll be a lot cleaner than what we see here. So -5, -4, -3, -2, and -1. Okay, so redrawing this graph, we're only going to draw where we have both values shaded. So starting with the left, we only have red until we reach -4, at which point we have a green parenthesis. So since there's a parenthesis, that means that number is not included, so we're going to put a parenthesis in our final answer. The red is included, but the green is not, so we have to say that number is not included with a parenthesis. We then have shading all the way until -2, at which point we have a red parenthesis but green shading. So we'll put a parenthesis at -2 and shade in between. This is the graph of our final answer. And with that, we can quickly get the solution, which is parenthesis -4, comma, -2, parenthesis. It comes immediately from the graph. And this solves the original problem that we started with up here.